So welcome to today's session. Good afternoon, guys, where we talk about Oracle workloads on hyper-converged infrastructure. So Oracle on steroids, an end-to-end solution for business-critical Oracle workloads. Standard disclaimer. Yes, we will not talk about Oracle licensing in this session, but if you cannot live without talking Oracle licensing, I will, at the end of the session, probably take some of the questions outside. There are really good sessions here. I think it's today and tomorrow, maybe yesterday. I don't know, was it yesterday? A while ago? Okay, yeah. Where we spoke about Oracle licensing. So yeah, any other deep dive Oracle licensing stuff, that session, this session is only to talk about bits and bytes of Oracle vSAN. Sorry, Oracle on vSAN. And before I go into the agenda, if you have any questions, if you can please hold off till the end of the session, that'll be really appreciated. If you have a burning desire to ask a question, that's all fine. Please come up here and feel free. That's the agenda for today. We have a lot of content. Some of the key takeaways that we would like you to take away at the end of the session, basically, the stringent requirements for business critical application. So whenever you hear the term BCA, or you hear me, or for that matter, any of my team members saying BCA, it stands for business critical applications. Oracle is just a use case here. Your BCA could be your Java workloads, your BCA could be your SQL Server workloads, your Exchange, your SAP, your Hadoop, or for that matter, any homegrown application that puts food on the table. That's how I define BCA to be, right? And what are the different challenges associated with meeting these requirements? And the third aspect is, how does VMware, hyper-converged infrastructure, help BCA workloads with all of these, basically trying to achieve performance, high availability, disaster recovery, business continuity. You have scalability, you have security, you have repeatability, recoverability, all of the abilities. How does HCI help Oracle workloads do that? So let's have a look at some of the characteristics of business critical application workloads, and this is very generic to any application here. Excuse me. We spoke about BCA requirements. They are very stringent, they are very strict, and these are like rules set forward by the business that say, hey, I need to have these SLAs, the RTOs, the RPOs. I would like to have availability, performance, recoverability, scalability, security. We spoke about that. This is one slide that I'd like you guys to pay attention to. So if you look at this slide, this is basically a design methodology. Right? So this is a design methodology whenever you do any kind of Oracle replatforming. So let's say if you were to move from the big endian to the little endian, not this endian, the endian, right? So big endian to little endian, where you move from the AIXS, the Solaris, the HPs of the world to, let's say, physical x86, or even virtual x86 for that matter. If you look at that, none of these changes. You still have to gather requirements, you still have to talk to the stakeholders, you have to get a big yes from them, you have to understand your current environment, right? And then you would go ahead and set up this target architecture, be that physical or be that vSphere. You would do some kind of database workload measurement, you would put your data in, basically doing database migration. Of course, you would make sure that you inculcate best practices in every layer of the stack so that your application is able to sustain the kind of workload that you have promised the business. You would make sure that you have high availability. You'll make sure that you have disaster recovery. Of course, backup and recovery. Every DB is bread and butter, monitoring and tuning. So there is no VMware in here. There is no vSphere in here. So this methodology is basically a very generic methodology that's applicable to every replatforming architecture here. I would say these are some of the benefits of running Oracle databases on VMware, not all of them, especially with vSphere 6. With 6.5, you have this VMFS 6 file system, and there are so many new features that VMFS brings to the table here. You have these NVMe adapters, 4 NVMe adapters per virtual machine, 15 per adapter. You have the PHY-12E emulator support for the PHY-12E devices, and so on and so forth, and the list goes on. But if I were to summarize, I would basically pick up rapid provisioning, good workload management, high availability, BCDR, consolidation, and of course performance. See, let's look at some of the typical storage concern of running, or let's say objections of running Oracle workloads on a traditional storage array. One of the most important things is basically scaling up and scaling out. There are a lot of issues there. You also have storage inefficiencies with regard to complex storage management. I have to manage this big storage fabric, this big storage farm. It's so many moving parts around here. Also added to that, you have this high development cost, CapEx and OpEx. So what I would like to do, or what we would like to do, is kill all these birds with just one stone. Right? And how do we do that? So basically, this is where VMware HCI vSAN comes and helps business critical application workloads.
Okay, so Sudhi discussed some of the challenges associated with the storage when you use traditional storage. How do you overcome those with vSAN, right? These are some of the technical and strategic reasons. So one is you evolve without risk. So use the native HCI security. vSAN provides native security, and the latest features provides resilient management and intelligent rebuild and resyncs, and then it provides a lower total cost of ownership, right? So you can do scale out, scale and scale up, and also it provides proactive cloud analytics. And then the last but not the least, the scale to tomorrow. So it is like optimized for performance. There is a lot of performance improvement in the recent vSAN 6.6. So, and added to that, there are the latest x86 servers are supported on vSAN. So the recently Xeon Scalable architecture is supported on vSAN from day zero. So as you can see, so vSAN started with the vSphere 5.5. Initially was a hybrid. So we have many release cycles, kind of a cloud-like release cycles, right? We've kept on adding features. So the latest is the 6.6, which actually some of the key features we released was the security, the enhanced stretch cluster, which we'll talk about more, and then of course the higher performance. Okay, so vSAN supports a broad variety of use cases, and one key thing to note is many of our customers have deployed business critical apps on vSAN, and that is the highest percentage is BCA apps, which includes SQL and Oracle. So on some of the key features released with 6.6, one is the vSAN data at rest encryption. So here again we provide a choice. So you can do encryption at the application layer using Oracle, or you can do at the VM level, which is the VM encrypt, or you can do at the vSAN level. So depending on the use case and the requirement, you can choose it. And then this is another key metrics which is very useful for testing your performance. Whether are you getting the enough performance from your vSAN cluster? If you're not getting, where is the bottleneck? So what this does is, so there is a logs which is sent to the VMware cloud through Phono. If customer enables that, agrees to that program, it sends the logs, just the logs, and none of the confidential information, just the performance data, and it analyzes and then gives you a recommendation. Oh, the performance is good, it says it's good. If there can be an improvement, it sends you a recommendation or a knowledge base on where is the bottleneck. Do you want to add more disk or more capacity in the cache tier? Is your VMD case balanced across the disk groups in the vSAN cluster? So it provides you a nice recommendation. Last, another thing, right? So the recent vSAN release is fully integrated in VROps 6.6. So what I mean by that is whatever the monitoring and analytics feature you were getting on vSphere, the same thing is also extended to vSAN. So back to the basics, right? So vSAN is native to the vSphere architecture. So it's a HCI, so the compute and storage comes from the same x86 server, and the other advantage is all the vSphere features, the vMotion, HCI, everything is supported in vSAN as well. So in the consumption models, depending on the thing, you have vSAN hybrid and all flash. Hybrid, where you use a mix of the flash devices and the hard disks, and in all flash you have the flash devices. So right now with the economics of SSDs and flash devices, so you see more implementation of all flash than hybrid. So some of the key collaterals, knowledge base released with vSAN on Oracle. So we initially released the knowledge base to support the Oracle RAC solution on vSAN. And then further, we did a comprehensive reference architecture which talks about Oracle RAC on vSAN. So even though that paper is written for hybrid, so it is equally valid for even the all-flash vSAN cluster as well. And then you can see we have done a reference architecture with Oracle on all-flash, which uses the space efficiency features of the vSAN 6.2, like erasure coding, dedupe and compression, etc. And then last but not the least, we also released recently a paper which covered day 2 operations, which is very critical for the Oracle database admins, like backup and recovery, cloning. So using the whatever inbuilt tools available within vSAN and vSphere. Okay, so having discussed the multiple flavors of vSAN hybrid, all flash, so some of the things doesn't change. Say the deployment of Oracle RAC or an extended Oracle RAC on vSAN hybrid or all flash is the same. And all the Oracle level implementation like the Oracle Data Guard, RMAN, everything stays the same even if it is hybrid or all flash, right? What changes is across the different vSAN version is the performance improvement, right? Thanks to the continuous innovation in vSAN software and also the x86 hardware. So you get a higher performance with the recent version of the vSAN. And of course, you also get additional features, thereby improving the total cost of ownership.
So basically, Parni went over all these new features of vSAN, right? So as one of the first collateral what we released the Oracle RAC 11204 on vSAN 6.1 hybrid. And basically, this is what it looks like. So we had a 4-node vSAN cluster, we had a 4-node Oracle RAC cluster. Each vSAN or ESXi server was 2-socket, 20 cores, half a terabyte of RAM, Oracle RAC nodes, 8 vCPUs, 64 gigs of memory. And basically, there's this whole concept of disk groups. So what happens is every ESXi server needs to have at least one disk group, and the concept is every disk group has a cache and a capacity tier, right? So with all flash is a bit different because all the reads go to all of the capacity tier. The writes in both the cases goes to the cache tier. So you basically write into the cache, and at some point of time, if the dirty buffer percentage increases over a certain threshold, that's when decaching happens, right? That's when destaging happens. In this case, the vSAN policy, basically the policy is a policy engine that we apply, right, to a data store, or for the matter, a VMDK. We basically said here in this case for a VMDK FTT. FTT stands for failures to tolerate. How many failures can I tolerate? So the equation is FTT equals n, right? The number of copies I need is n plus 1, and the total number of hosts is 2n plus 1. So if I can tolerate one failure, I need to have 2 copies, and I need to have 3 servers to have those 2 copies. Number of disk types is set to 2. OSR here stands for object space reservation. See, typically if you set up Oracle RAC on a vSphere cluster, right, the key thing as per KB article 1034165 is those shared VMDKs need to be eager 0 thick, which means when you create that VMDK, you create it thick. You put all zeros in that and make sure it's a thick eager 0 provision device. OSR stands for that, object space reservation. So when I create my shared device on a vSAN cluster, I would like that shared VMDK to be eager 0 thick. That's what 100% stands for. The rest of it was set to default. That's pretty much what I'm talking about. So the concept of setting up an Oracle RAC on vSAN, like Parni explained, is no different than setting up Oracle RAC on a vSphere cluster. A couple of things to keep in mind. All of the best practices still apply here. So for example, multiple PB SCSI controllers, right? Even the Oracle best practice say that. Don't use just one PB SCSI controller. You have an option of using all 4, please use all 4. Every PB SCSI controller has a max of 15 VMDKs, right? Try to stripe or try to spread your VMDKs across all of the PB SCSI controllers. The reason, queue depth, because there are queues everywhere. You want to make sure that you do fairness, you do load balancing, and you also take care of queue depth, right? Especially when you come into the Oracle arena or the Oracle landscape, right, and if you're using ASM, you want to use multiple ASM disks in a disk group, not just one or not just two, so that you spread everything across, you stripe it thin and wide, right? So the steps for setting up the multi-writer is exactly the same as in a traditional vSphere cluster. And what we did was we said, hey, you know what, we need to run a couple of tests to see if this solution is really feasible. So we ran the performance test, the scalability test, we ran the resiliency test, we ran the vMotion. So basically with resiliency, we unplugged a single disk, right? A single disk and said, hey, does anything happen? How does vSAN react? Does everything crash? How about a disk group? If I were to take an entire disk group offline, what happens? And how about if I take an entire host offline? Does anything happen, right? So vSAN was able to recover from the cluster very fast and make sure that the Oracle rack cluster does not crash. But I would like to focus on the vMotion aspect of it because that's something what interests Oracle DBA. Question from the field. If I'm running Oracle rack on vSphere and if I do a vMotion, what happens to my Oracle rack? Do I have a cluster node eviction? Does bad thing happen to Oracle rack? And the answer is a big no. Nothing happens. So basically we used the swing bench load generator, 100 users, right? And it was a complete read-intensive workload, and we hit the Oracle rack cluster very hard. And what happened was, we were able to get 300,000 TPM, and then when we started the vMotion operation, which basically took 182 seconds, during the last 10 seconds, there was a bit of dip in the TPM, which was expected. But then once the vMotion finished, it ramped up all the way to the first. So case in point being, vMotion of an Oracle rack cluster, yes, you can vMotion an Oracle rack virtual machine all day long if you have nothing else better to do. But case in point being, vMotion does not affect any cluster, any Oracle rack cluster. Of course, you have to make sure that you have best practices, right? I wouldn't recommend you guys to run a gigabit. I wouldn't do that. And then again, you can run a gigabit if your interconnect bandwidth is less than half a gigabit. That's fine too. But typically we say have 10 gigabit to make sure that you have enough adequate bandwidth to push as much cluster or cache fusion traffic, as we call it in the Oracle land, to go from one server to the other.
Okay. So another interesting solution we built with the Oracle rack is using the vSAN stretch cluster. So what we did is we took advantage of vSAN stretch cluster to provide storage, shared storage to the Oracle extended rack cluster. Actually, in this diagram, you can see the Oracle rack node. One of them is in site A and the other one is in site B. And similarly, you can see two ESXi hosts on site A and another two on site B. So they are active, right? And so the distance between the sites, right, what we currently support is the latency should be less than 5 milliseconds. And then you see the site C is just to store the witness of the vSAN. So just to take care of the vSAN stretch cluster in case of any kind of split brain situation, you need a witness, right? So again, we did some tests using the same swing bench. We'll go to we'll see the test results. One key thing to note it, right? So with vSAN 6.6, we did an improvement on this stretch cluster feature. Basically, now we have redundancy locally and across sites. Earlier, you had one copy on site A and another copy on site B. So just mirror between sites. That was just across sites. But right now, you can have this copy, one copy on site A, one copy on site B, and also you can have protection locally as well. Say you can have a RAID 5, again a RAID 5 locally on site A and a RAID 5 locally on site B. So this will help you in case of site failure. In case of even a complete site failure, you still have protection even at the local site level. So this was one of the feature customer asked when we introduced this feature earlier in 6.1, I think. Now we have that as well. So it's very useful for the business critical application like Oracle. Okay, so this again we used, this is kind of a near zero data loss solution. We used, for the metro distance, we used the Oracle extended rack solution using the virtual SAN stretch cluster, and for the global distance, we use the Oracle Data Guard for replication. So that's what you see here. And then the other thing you can note in this solution, now you can also offload the backups to your DR side. So the RMAN backups can happen from your vSAN cluster, which is in the DR side. So this would be a cool solution as well. So having discussed the virtual SAN stretch, the vSAN stretch cluster, we did this performance testing using the swing bench. Sudhir discussed about the swing bench test we did on vMotion. The same workload was applied on this 2-node extended rack, right? And here, what we did is, so to simulate the distance between the sites, we increased the latency. We tested for 1 millisecond round trip latency, 2.2 millisecond, and 4.2 millisecond, and we observed how the transaction per second behaved. So let's go to the results. So the TPS comparison chart shows you the blue one is the baseline, wherein you don't have any latency between the sides, meaning all the 4 nodes are in the same site. And then the next bar, the orange one, is when the latency between the site is 1 millisecond. As you can see, due to the increase in latency, you can see the I/O reduction, and also due to the Oracle cache fusion message latency, you can see the TPS dropped as the latency between the sites increase. So from when compared to the baseline, you can see the 1 millisecond latency, which is like 100 kilometer, it provides like 88% of the transaction when compared to the baseline.
So a quick thing to add here, right? When we see the TPS reduced by 12%, 27 or 47, it basically depends upon the kind of workload, right? So the kind of workload that we ran, we saw these numbers. So your mileage may vary, your TPS may basically reduce by a lower number. So all I tell my customers is, know your workload very well. If you have to run it, right, absolutely it will. There are some customers who even take advantage of Oracle rack services to make sure that the cache fusion traffic doesn't go across the wire. But case in point being, it's completely dependent upon your workload, the kind of workload that you run.
Right. So what we discussed now regarding the Oracle rack solution is comprehensively discussed in this reference architecture, which is available in the Storage Hub VMware site. So next, we'll discuss about the Oracle workload testing we did in all-flash vSAN cluster. Again, in this solution, we had a 4-node vSAN cluster where we had Oracle database 12c. Here we used all the 6.2 features, the space efficiency feature like RAID 5, RAID 6, and also dedupe and compression, and also we enable checksum, which provides data integrity. So we did multiple tests. So one is OLTP workload, where we use the SLOB, which is kind of used to test the I/O for the Oracle databases. And then we did DSS like workload, and also a mixed workload where some VMs doing OLTP and other VMs doing a DSS sales history workload. So today we'll focus on the DSS workload.
Go back to the previous slide, please. See, that's the last line that I want you guys to focus on. Performance data is basically a result of the combination of your hardware configuration, your software configuration, the testbed, the tool, and the profile. So like I said before, the numbers may vary from customer to customer, but that's a key thing that we have to keep in mind. Go ahead.
So in the DSS workload test, we use swing bench. We use the sales history workload, which is like 100% read IO intensive workload. And the vSAN policy which was used was kind of mixed protection, wherein for the data disk we used RAID 5, and for the redo logs we used RAID 1. So which provides benefits of space efficiency and also performance as well. And we also enabled dedupe and compression at vSAN level, and checksum was enabled. And we had two database VMs, and we applied a DSS workload using Swing Bench simultaneously on both the VMs. So this is what we observed. So this is this graph is from the vSAN observer, which is where you see the performance metrics of a from vSAN perspective. So you can see the total read throughput on the vSAN cluster was the average was 640 MB per second with a peak of 935 MB per second, and you can see the Oracle from the Oracle AWR as well. The physical IOs read IO throughput is average is also around 640 MB per second. So based on the testings we did with this, and it's in the reference architecture as well. So not alone vSAN is viable for OLTP, you can also use for the DSS like applications as well. Yeah, so again, this reference architecture is also in the storage hub.
Sure. So we have, at the end of the deck, we have a slide that basically has all of the collaterals listed out. I don't know if you guys know, it's aptly called one-stop shop, taking care of business, right? So anything and everything to do with Oracle on VMware SDDC, you'll find it here. But moving on.
When will these presentations officially be available?
Probably by next week, we should have that. Okay. All right. So basically, Parni covered, and I covered as well, the day one operations where we are able to provision a 2-node or a 4-node Oracle rack cluster on vSAN. We were able to stretch it across metro distance, right? And at some point of time, we even gave it high availability, right? Disaster recovery. We made sure that it has backup and recovery set in as well. But what happens is a key aspect to any IT operations is also day two, wherein you also do backup and recovery, you do cloning, you do data refreshing, patching, so on and so forth. So what happened was we said, hey, you know what? Now having done everything, can we see if vSAN also helps it with doing these normal day-to-day operations, especially with Oracle, with day two, right? And the features in the tool we use were basic native vSAN tools. So using vSAN snapshot, using vSAN clones, and on the Oracle landscape or the Oracle land, we basically used the Oracle backup and recovery methodology, right? So these were four use cases we came up with, right? So database backup, as everybody knows here, you can either do it in one of the two ways. Either use hot backup by setting up your database with a begin backup mode and end backup mode, or if you choose not to, you can even do a crash consistent backup, in which case you take a snapshot of an Oracle database. When Oracle comes up, it says, okay, I'm going to do an instance recovery, right? Oracle RMAN is another way of doing stuff, but we won't talk about Oracle RMAN here. Coming back to the vSphere land, if I have to clone a virtual machine, or let's say a set of VMDKs, I can do it in one of the two ways. I can take a snapshot of the virtual machine and clone from the VM, or I take a snapshot of the virtual machine and using VMKFS tools, I can just clone those VMDKs that I would like to clone. So let's look at one of the use cases here, right? In this case, we had a production virtual machine, Aura 12C OL73 running, and the use case here is I have to take a snapshot, clone this production database, right? And I have to recover it because I need to get some data from this particular virtual machine. Or for that matter, I just want to clone this production virtual machine. How can I do it in a fast, easy, a seamless way without paying money for any third-party tool, just using the Oracle native tools and by using vSAN native tools? So the steps are, you basically will put your database in a hot backup mode, take a snapshot of the virtual machine, in backup mode. Once you take a snapshot, clone using VM cloning, clone a virtual machine from that snapshot. When you're done, delete the snapshot because you don't want the snapshot to lie around. Now that you have a fully functional cloned virtual machine, start it up. When you start it up, Oracle database will not come up because you manually put the database in a backup mode, so you would have to perform a media recovery, right? So you'd basically say recover database until cancel or recover database until SCN, blah, blah, blah. And once that's done, what you have on the other side is a copy, point-in-time copy of this production database, right? So that if you have to look in here and retrieve some data, or you have to fix some issues, or for the matter, if you have to create a clone of the production database, you have it here. So that was this use case. The second use case was, okay, fine, this is all great, right? But what if I just need to take a snapshot of the VMD case? I don't want the operating system device, the disk snapshot. I don't want the Oracle mount point snapshot. All I'm just interested in is a database VMD case snapshot. So the use case here is you have 3 production databases, right? And I just want to replicate, or for the matter, I just want to take a copy of production database 1 and bring it over to virtual machine 2. The steps are exactly the same, which means you would set up the database in a hard backup mode, take a virtual machine level snapshot, end backup mode, but then instead of cloning a virtual machine from this snapshot, you would just use VMKFS tools to clone those database VMD case that you want to bring along to the other side, right? And once the cloning operation is done, delete the snapshot. Like I said, you don't want the snapshot to lie around. The only thing that we have to do then is to attach these cloned VMD case. You would just attach it. Attach it to a new PV-SCSI controller on the target virtual machine. That's all. All you have to do is go into the operating system, scan the bus, you see those devices, and if you're using Oracle ASM, you would run a command, Oracle ASM scan disks. You would see those disks when you run the list disk command, voila. ASM is up and running, and you have a fully functional copy of production 1 database running on VM2. So either of the 2 ways, either I take a fully functional copy of a production database in a virtual machine, or I just copy the VMD case of a database among a set of databases in a virtual machine, whichever way I want to. You can be creative. See, the third use case is basically refreshing, right? Even before I go into that, let me ask you, how many guys are at Oracle DBS? 2, 3, 4, 5, 6. 6 Oracle DBS. How many times do customers come and say, or for your own internal BS come and say, hey, I need a copy. Can you please refresh this QA instance for me, please? Can I please have a copy from this production database? And what you would do, and probably what I did a couple of years ago, write scripts, Oracle export, import, Oracle data pump, tear my hair apart and try to get this data from here to here, triggers, referential integrity constraints, disable it, enable it, get the data in, and then somebody comes and says, hey, I have duplicate data here. Okay, go back to the starting line, right? This is really frustrating. In this case, what we would do is, for example, and you know what, I want to throw a curveball here. A one-to-one, which means if I had to refresh or clone a production database to a virtual machine which has nothing running, that's easy. But what if I had a couple of QA databases here, QA1, QA2, and QA3, and I just want to refresh QA1, right? It's the same methodology, right? Once I have a copy of this VMD case of the production database, all you need to do is go ahead to QA1, drop the QA1 database, get rid of the VMD case, get the cloned VMD case in, target VM2, scan the bus, scan ASM, but what you have is a database with the name prod1. Of course, you would use your database tools, dbnerd, right? dbnewid, dbnerd, go ahead, knock yourself out, change the name of the database, voila. You have a copy of the production database. So all we're trying to show here is you can use vSphere/vSAN's native tool, snapshotting, cloning, along with the Oracle native tools to do any of your day 2 operations, right? There are a couple other use cases we did as well. Patching, patching an Oracle rack. If you have to patch an Oracle rack, can I take a copy of the Oracle rack databases? It's a bit screwy there because of the multi-writer flag, but then we were able to do that as well. If you have to do refreshing, if you have to do cloning, how do I do it? And all of that can be found, the details can be found here in this white paper. Like I said again, at the end of the deck, there's a collateral page where you'll find all of the links. And this is something we did this year. These are some of the partner certified data protection solutions for day 2 operations. You have Veeam, you have Dell EMC. All right. So basically trying to bring it together, right? So at some point of time, we spoke about Oracle Rack, traditional, stretched across metro distances. We spoke about adding disaster recovery. We spoke about backup and recovery to the Oracle workloads. And at some point of time, I said, hey, with the advent of Oracle 12c, I would like to run a read-intensive workload, write-intensive workload in these Oracle databases, right? Can I do that? Can I run an OLTP environment? Can I run a DSS? Can I run a mixed workload? Can everything run together, right? What is the latency requirement? Or what is the kind of throughput did I get, right? What are my response times? We saw that as well. We also saw day 2 operations where we spoke about backup and recovery, cloning, data refreshing, patching, so on and so forth. See, there's one thing that's missing here is all of the stuff we did so far, it's all manual. It's something that you would have to do using your keyboard or your mouse, right? Click, click, click. What if we were to automate it? Can we automate it? The very first thing. What if we can automate it? If we can automate it, especially for service providers, right? The service providers would have to do this on a regular basis, every minute of the day, every hour of the day, for new customers. Even you guys would have to do it for your BUs or your customers, right? Doing this repetitive task day in and day out really takes a lot of cycles from your mind. What if I can automate that for you? See, one of the use cases here, and one may stand up and say, Oracle RAC automation, oh man, that's really difficult. It's not very difficult, and the reason why people shy away from automating or from provisioning Oracle RAC is all of these. It's very complicated. There's a lot of moving parts, right? There's a network part, there's a storage part, there's a compute part. You have the SCAN and a single client access network. You have the VIPs, virtual IP. You have the private, and then you have the public, and then you have the node name, right? And then every year Oracle comes up with the new nuances, HCI, and at some point in time even I got confused, right? But what? From your perspective, from the VMware admin perspective, if you had to provision an Oracle RAC in a couple of minutes, right? How would you do that? That is database as a service, and that is a solution that we are working on currently as I speak. As of now, we were able to provision a single instance database, Oracle RAC virtual machines, without any user data from a self-service catalog. The solution also has a decommissioning an Oracle RAC. We were also able to define templates of Oracle database virtual machine to be available. The other important aspect that I am working on is currently metering and reporting, right? So now you have these Oracle DBAs run wild, right? Basically they come to the VMware admin and say, hey, I need the entire server, right? Give me the entire server, because you know Oracle is a beast, I need the entire server. Metering and reporting. Basically use a chargeback model. Basically you can use a showback model to go and say, hey, you asked me for so much, that's all fine. Hunky and dory, right? But now you gotta start paying for that. Because you know what, thing ain't cheap, right? Provisioning clones of Oracle RAC databases, and also if I have to migrate database from a traditional model to a database as service model, how do you do that? So this solution encompasses like 13 to 14 use cases. Hopefully by the end of the year, after VMware Barcelona, I should be able to get this done, and you should find that in Solution Exchange in one form or the other. A couple of case studies. So if you guys are looking for public references, it's there on our website. You know, Telefonica, Watcher, Union Hospital. But this is something I want to go through with you guys. So what happened was I got pulled into a vSAN POC, proof of concept, right? So then I go in, and basically the Oracle guys, the VMware guys, they said, hey, we followed all the Oracle RAC best practices, stuff that you wrote in that 82-page document. I followed every word of it. I was very happy. We followed every vSAN best practices, but then I had some performance issues. I started looking into that, right? And what I found was a log file sync. That event was very high, 13 milliseconds. Yeah, that's really bad, 13 milliseconds for a log file sync. So I had to use my Oracle DBA cap, do a lot of tuning, and at the end, I reduced it to 2.66, and I even asked the guy, can I reduce it any more further? But he's like, no, you know what, you have convinced me. I am a believer, and I am going to put my Oracle RAC, or for the matter, Oracle databases on vSAN. One may ask is, what is the secret thing that it did, right? There's nothing secret. DBA forgot to tell me how the redo log file was laid out on the physical architecture. So basically he had multiple redo log groups with multiple members, and when we set it up in virtual, he basically said, oh, it's 2 redo log groups with 1 member each. The reason why I want to point it out is all of the stuff we do in physical, when you want to move it to virtual, you want to make sure it's set up in the same way. Or else at some point in time you'll go back and say, hey, running Oracle RAC on vSphere, it doesn't scale, it sucks. No, it doesn't suck. You basically didn't do your homework. So this is what I would like to point out here. Some of the best practices of running Oracle on vSAN. The first thing first, what are some of the best practices of running Oracle on vSphere? None. Why? Running Oracle on vSphere is no different than running Oracle on vSAN, or for the matter, running Oracle on any other architecture. The question that you need to ask is, yes, Oracle will run on vSphere. Will it run optimally? Will it run at that rate at which I want it to run? And that's why we come up with all these best practices, right? Like IO scheduler, turn it to no op. I know I've spoken to a couple of you guys during the Oracle bootcamp we had this weekend, right? Turn the IO scheduling to no op, right? Use memory reservation, don't oversubscribe. By not doing that, nothing bad will happen to you. It just won't perform. It is just like saying, hey, I went out to the market and I bought the biggest and the baddest servers on the face of earth. But I misconfigured something and it didn't work. And I had to go back and say, oh, don't buy the server from that vendor. You know why? The thing doesn't work, man. No, that's not it. You did not do your homework. That's the underlying thing. So some of the best practices, No difference. Use multiple PV-SCSI controllers. Make sure that you have multiple VMDKs. You stripe it among these PV-SCSI controllers for queue depth, for load balancing, for fairness purposes, right? And I know we have virtual NVMe adapters as well, so absolutely, please use those. The other thing that I've seen so far is I/O scheduling, right? Our recommendation is turn off I/O scheduling in the Linux guest operating system. The reason is ESXi has its own I/O scheduling, guest operating system has its own I/O scheduling. You don't want both the minds to think at the same time. You want to shut the guest operating system I/O scheduler off so ESXi can do what it is born and bred for, right? And all of these recommendations, these best practices can be found in this best practices guide. Currently it's close to 82 pages. Hopefully I add more at the end of this year.
Yeah, so some more best practices specific to vSAN. One is you want to design for growth. So when you have a ESXi host, right, you want to have a similarly sized ESXi host across the vSAN cluster. And you also wanted to consider your cache sizing, everything, keeping in mind of your future requirements as well, so that you have similarly sized cache tier and disk groups when you want to do any kind of future capacity addition. And then you want to design for availability. Right, so it's depending on the FTT, right, failure to tolerate setting you set. You wanted to have additional host and capacity in case of any failure, so that there is enough capacity for it to rebuild, right? And at the same time, also provide you a desired level of performance when there is a host failure or a disk failure. Next thing is SPBM. Take advantage of SPBM. So this actually provides you a very nice feature and very granular level at the VMDK disk level. So you can choose for some disks RAID 5, say data disk RAID 5, redo disk RAID 1, like that. And also you can do, you have a QoS functionality which you can do at the VMDK level. And then you have, for latency sensitive application, you can use RAID 1 for both data and redo. And for other applications, you can consider using RAID 5 for data and RAID 1 for logs. So which will provide you a balance between the space efficiency and performance. And then in using the vSAN dedupe compression, right? So how much benefit you get, it depends on the workload, application workload. So you either enable at the application layer or at the vSAN layer, not at the board. So you don't get benefit if you are already turned dedupe compression at the application layer. And in vSAN, the domain for the deduplication is at the disk group level. So typically a larger disk group will provide you better deduplication ratio. So probably you need to balance your disk group accordingly.
All right, so in conclusion, definitely all of the features that we're looking for, right, the requirements that is necessitated by BCA, basically performance, reliability, you need to have recoverability, you need to have scalability, availability, disaster recovery, so on and so forth, can and will be provided by HCI, hyperconverged infrastructure, by vSAN. Spoke about some of the useful collateral. Yeah. So if you go down to this link, you pretty much have everything, including Oracle licensing. So I said, yes, we will not use the L word here. We could use the L word once the session is done, and I can answer your questions. But that's the link, and you guys will get the deck probably by next week. Should. Some Oracle references: Oracle Rack and vSAN, 12c and vSAN. These are reference architectures that we spoke about, Palani and I. And if you're looking for technical deep dive, Oracle vSAN, that's the link. It's got really good documentation, especially if you want to read about FTT or OSR or about disk groups or even about NVMe. Everything is up there. Some of the vSAN key activities at VMworld. I need to become a vSAN specialist. So that's my next thing. Yeah. 3 easy ways to learn more about vSAN. You have hands-on lab, technical library, tools. Please let us know about your experiences of running Oracle on vSAN. That's me, my background. I don't know if you guys know me, but 20 years of Oracle background. Been doing databases since 95. Started with 6. My college project was Oracle 6. So 6, 7.3, 8, 8.0, 8.15, 8.17, 9, 10, 11, 12, and I don't know what 13 is going to be. Whether it's going to be 13C or 13K, who knows? That's me. That's my book. I have a couple of copies. If you guys are interested, please feel free. Tony.
Yeah. So I'm a senior solution engineer with the vSAN product enablement team. So my team developed a lot of reference architectures on business critical applications, and I specifically work in Oracle solutions on vSAN. And so I have like 11 plus years of experience with many storage vendors, primarily EMC, IBM, etc. So I have experience in professional services doing migration, storage migration, implementation, deployment.
Questions, including the L questions. That's fine. I'll take those. Yes, sir. Could you, if you don't mind, could you please continue? So I want everybody to hear your questions.
I am into sales. I am a Dell EMC employee. So typically when we are proposing solutions, specifically in BFSI sector or manufacturing sector, it's a mandate that we segregate the production and UAT. So if I have to create a minimum 3-node cluster for production, still fine, right? But if I have to segregate and create a new 3-node cluster for UAT, customer is bothering about it because I don't have, if it is a physical server, it just needs a 4-core system. Okay, so how do we address this? One of the ways that I probably thought is go for a physical server, map an iSCSI mount point on the cluster or an external storage. But is there any other best practice for segregating the physical production environment and the UAT by not going with the 3-node cluster in the UAT?
So basically what you're saying is, if I understood your question correctly, correct me if I'm wrong, right? You have 2 environments. You have production and UAT running on the same vSAN cluster, right?
No, it has to be separate.
It has to be set separately. So your problem is not, or your question is not to run?
No, I need a 3-node cluster. I need to invest in a 3-node cluster in production. I also need to replicate the same thing for UAT.
Oh, okay.
So how do we address
But he doesn't want a 3-node,
Exactly.
separate 3-node cluster.
Yeah.
Okay.
One thing is you can take advantage of iSCSI feature in vSAN, which we support for Oracle as well, even for Oracle RAC, right? So
Oracle
for
RAC also is supported.
Oracle RAC also is supported on Linux. So you can take advantage of that. So for your UAT, you can use iSCSI.
That's what I have proposed. I
Yes.
just wanted to reinforce that.
Yeah, absolutely. And
Yes.
you can, as an iSCSI target, yes, you can do that. See, any other questions? And I've thrown the floor open for even licensing. That's fine too. I'll take those. There cannot be one Oracle session where you don't have a licensing. Come on, guys.
I think you showed a separate site saying no licensing. That's why I think.
But that was at the start of the session where I said no, you can't use the L word, and now I'm saying
Okay, now
you can use the L word. So
Okay.
yes, go ahead.
I have another question.
Absolutely.
Are there any benchmarks for the iSCSI? The second concern which came in from the bank was performance of same on iSCSI. So
What's the benchmarks for running iSCSI?
Okay.
Basically, your vSAN data store is an iSCSI target.
Oh, okay.
We have those.
I think we don't have anything currently like a publicly released things, but the performance at iSCSI, right? There is some overhead, but kind of it is not like very bad or something. There is a overhead.
good to go for a UAT.
Yes, definitely good to go for a UAT. There is not much huge difference.
See, the other thing that you'll keep in mind is the replication, right? How much are you replicating across a wire? It's basically the same thing as saying one server to the other, right? How much are you replicating across a wire, and what's the bandwidth, right? If you have adequate bandwidth and your rate of change is not much, I don't see a reason why you can't use iSCSI, right, as a target for your UAT. But wasn't there a paper that was released? I thought
No.
would be. Or might be, could be, I don't know. Okay, that's fine. All right. Any other questions? All right. Thank you, guys.
Thank you.
Feel free, there are a couple of copies of my books here. Feel free, help yourself.